Hello, Pre-Calc Honors. This is Mrs. Crayer here. I am on page 8 of the note packet using definition of derivative. So now that you've done all the algebra and you've had to, multiply x plus h squared out a bunch of times, distribute things, condense, then find the limit and all that stuff, that's the lengthy part. We're basically done with that. But you will have questions where you'll have to recognize that something is plugged into the definition of derivative. So this is not just a regular old limit question. I'm looking at number 1. This is something plugged into the definition of derivative. And I am going to apologize for my writing in advance because it's not going to be great, okay? It's not going to be great. Limit as h approaches 0, f of x plus h minus f of x all over h. That's the definition of derivative. So looking closely at number 1, I can tell that that's the definition of derivative. We should be familiar with it enough at this point. The question is, well, what function are they using? That's what our job is now, is just to be able to pick out the function. And the function that they are using is x squared. Now, if I think back, if I were to take, x plus h and plug it into x squared, this is what it would look like. And then it would be minus the actual function itself. Okay, so that tells me that the function must be x squared. Okay, this will be useful when we have a shorter way of finding the derivative, which is coming in the next, I almost said episode, the next lesson. But for right now, it's just a matter of like, hey, I don't have to go through all the algebra. Not that it would be terrible in number 1, but if you're looking ahead to number 3, it's like you don't have to go through all the algebra. If you can pick out the function, this is going to be super easy to take the derivative of. Okay, I'm just going to do a few of these and then I'll let you guys kind of pause it and see if you can do the rest. This is actually a super fast lesson. Looking at this one, I can tell that the function that was plugged into definition of derivative is x cubed. And x plus h was plugged in here and then minus the function itself, x cubed. In the next one, now, if they have the function sitting right after the subtraction sign, in parentheses still, then I know the negative was not already distributed through. So I can go ahead and just grab that guy and say, hey, there's my function. When that negative is distributed through, that can get a little bit tricky. So if I'm looking at the front portion, I can see that an x plus h plugged into what I wrote down makes sense. 3x plus h squared plus 2x plus h plus 5. The only thing that can be tricky here would be missing a negative or, something like that because you're looking here, but the negative was already distributed through. Let's see if I have one of those. Okay, I think number 4 is going to be just as easy. Let's go to number 5, because in number 5, the negative is already distributed through. So if I'm trying to figure out what function was plugged into the definition of derivative, and I look over here and I go, oh, I'm just going to take that has to be f of x, that would be wrong, okay? The negative is clearly already distributed through because there's no parentheses there. So it's 2x to the 5th minus 5x cubed. If I look at this part, basically wherever I see an x plus h, I'm just going to put an x because the whole first part of the definition of derivative is taking an x plus h and plugging in it. Okay, moving down. Sorry, I'm not great with this program, but I'm trying. Okay, I think you can check the answer key for most of these. 7 is going to be sine x. I think that's pretty obvious. 8's going to be e to the x. And just to kind of work backwards here, if I'm using the definition of derivative and I'm plugging in the function, it's going to look like this. And x plus h gets plugged in here. That's why it's in the exponent. And then minus the actual function, e to the x over h. Oh, that looks terrible. I'm sorry, but hopefully... Oh, I gotta erase that. That looks so bad. But anyway. And we don't know how to solve this one algebraically, but we'll learn the derivative of e to the x soon. Here, the function that was plugged in was ln of x. Okay, looking at number 11, it's giving us... Oh, wait, I skipped 10. Let me go back to 10, sorry. Looking at number 10, it's giving us limit as h approaches 0 of some function was plugged in equals that. Okay, so if it equals that, that definitely means my derivative is 4x, because the answer to the whole, like once we do all the algebra and blah, 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 take the limit, we get the derivative. So what was the function? The function, I can see that the negative was already distributed, so it should be 2x squared plus 3. I can get that from here. Or I can get that from realizing that the negative was already distributed through. That one is going to be choice C. Okay, the last one, they're giving us a function, they're giving us the derivative, the answer to the derivative. We just have to pick the one that's plugged in correctly. And if you just take a minute to look at all those choices and think about what you think it is, which one of those has... Oops. It plugged in correctly. Choice A. Okay, moving on to the next page. Okay, oop, I didn't realize that had started recording already. I'm on page 9, using the definition of derivative at a point. This is a little bit harder than the last page because we already have a number plugged in. So this is saying this is the derivative at 3, but I still want to know, like, what function are we talking about? This is giving me the derivative at 3 for what function? And in the first one, it's x squared. How do I know that? Because if I'm taking a limit as h approaches 0 at 3, this is what we did, I don't know, I would say a couple days ago, but at this point it's probably a week. It would look like this. We would have plugged the 3 in already. So now it's a matter of figuring out what function that is. Well, it looks like 3 plus h is plugged into x squared. It looks like 3 is plugged into x squared. In the next one, this is the derivative specifically at 5, but the question is, what was the function? The function here is, try and think about it before I say it, 2 x squared minus x is the function. I actually think it's easier to look at the first part with the, in the other one, the x plus h is in it, and in this one, the 5 plus h in it, because that's, let me grab a highlighter. This is going to be my function. Just everywhere I see a 5 plus h, it's an x. Okay, in the next one. Oops, I want it to be on my pen. F of x equals, I'm looking at the front portion of this before I get to that subtraction. And if I think about a 2 plus h being where x is, it's x squared minus 3x plus 2. That would be my function. The next one, f of x equals, this one's going to be x squared. So why is there a 16 there? Because they already squared the 4. Okay, instead of looking at it like 4 squared in there after the subtraction, they just already squared it. Okay. Number 5. Okay, I'm so bad at this program. Okay, f of x. Again, looking at this one, might be able to have 2 answers unless I changed it. I'm looking at 3 and I'm replacing this with an x cubed minus 2x squared. And I'm putting the plus 1 in the function. And then I'm treating this as the thing after the subtraction. And I'm just going to double check that. If I plug 1 into my function, do I get 2? Okay, so I would just check. F of 1 is going to give me 3 times 1 cubed minus 2 times 1 plus 1. 3 minus 2 is 1 plus 1 is 2. So that checks. That if this is the function, and I plug in 1 plus h, that's what it looks like. And if I plug just a 1 in, I get 2. That's why that's after the subtraction. Number 6. The function that pi was plugged into and then plugged into the definition of derivative is cosine x. And in the last one was ln of x. Okay? All right, so there's pages 8 and 9. Hopefully that wasn't too bad. If you have any follow-up questions on that, feel free to send, post them in Google Classrooms, either under the video section or under the answer key section once you do the homework and get the homework the next day. And Mrs. Faber or myself will try to answer those as soon as possible. All right, I hope everybody's doing well. Bye.